Hi students, welcome to my channel, Crack Physics with Anisha. Let's make physics concepts simple, fun and clear. Next question. The value of magnification m for a lens is given as -2. Using new Cartesian sign convention and considering that an object is placed at a distance of 20 cm from the optical center of this lens, state the nature of the image formed, the size of the image compared to the size of the object, the position of the image, and sign of the height of the image. So one by one we can solve it. So given that the magnification of the lens is -2 and also the object distance is given. Object is placed at a distance of 20 centimeter from optical center. So object distance is also given as 20 centimeter. Applying the sign convention, we know object is always kept towards the left of the lens, to the left of the optic center. So we take it as negative. Now, first what we have to find? The nature of the image formed. What type of image is formed? How we can find it? By observing the magnification value itself, we can say the nature of the image. As a shortcut, you can learn it. If magnification value is negative, it will be a real image. Real image. And if magnification value is positive, it will be a virtual image. And now we can find how we are getting it as a real image and virtual image. Yes. So the method to find whether it is a real image or virtual image, that is, we know the equation for magnification. Magnification is equal to hi by ho, height of image to height of the object. We know that height of the object will be always positive. Why? Because the object will be kept on the principal axis, above the principal axis. And height of the image, its position changes. If it is a real image, it will be inverted. If it is inverted, definitely height of the image will be taken as negative. If it is a virtual image, the image will be erect. Then the height of the image has to be taken as positive. Isn't it? Yes. So it is height of the image that decides the sign of magnification. Now, if magnification is negative means height of image is negative. If height of image is negative means it is an inverted image. If it is an inverted image, it is a real image. That's how we can say that a negative magnification value gives real image. From the object distance and image distance also we can say this, that equation also. That one we'll see in the next questions, coming questions. Now, anyways, next question is the size of image compared to the size of the object. Yes, very interesting question. What will be the size of the image compared to size of the object? Now, remember, the sign of magnification decides whether it is a real image or virtual image. And the value of magnification decides its size. Remember, if the magnification value is equal to 1, if it is equal to 1, that means it is a same sized image. That means height of the object will be equal to height of the image, isn't it? If the magnification value is greater than 1 means if it is 2, 3, 2.5, 3.5 like that, we can say that it would be an enlarged image. Why? Because there numerator will be greater than denominator. Height of image will be greater than height of the object. If magnification value is less than 1, we can say that it will be a diminished image. Why? There the numerator is less than denominator, height of image is less than height of object. So the value decides the size, not the sign. Okay. Don't consider the sign. Sign only says whether it is real or virtual. The value decides the size. Now here it is given as the magnification as 2 means it is an enlarged image, isn't it? It is an enlarged image which is real and inverted. Now third question. The position of image. Position of image means we have to find the image distance, isn't it? Yes, where is the image located? The image distance. Using magnification value, we know HI by HO is one equation. Another relation is there for lens magnification. M is equal to V by U. U value we know, M value we know. So what is V? V is equal to M into U. Now what is M? It is minus 2. U is minus 20. So negative and negative become positive. 2 into 20, it is 40. So 40 centimeter. This is the image distance, or we can say the image is 40 centimeter from the optic center on the opposite side of the object. Yes, you can see the image distance is positive. That means what? It is on the opposite side of the object. Yes, opposite side of the object. If it is an opposite side of the object means here definitely we can say it is a real and inverted image. The lens is making the image on the other side of the object. That means it will be real and inverted image. Yes, there is a position of image. Now, fourth question is sign of height of image. Yes, height of image. We know magnification is negative. If magnification is negative, definitely as in the previous discussion, we have seen that the height of image will be also negative because height of image decides the sign, isn't it? As it is an inverted image, we can say it will give a negative value. That's how we are solving this question. The numerical values of the focal lengths of two lenses A and B are 10 centimeter and 20 centimeter respectively. Which one of the two will show higher degree of convergence or divergence? Give reason to justify your answer. Now, degree of convergence and divergence, what does that mean? Which quantity is represented as the degree of convergence and divergence of a lens? Yes, it is nothing else, the power of the lens. So we have to find which lens has greater power and then give the reason. Okay, yes. So the focal length of lens A is given as FA, we can consider that is 10 centimeter. Now, B lens is having a focal length of FB as 20 centimeter. Either you can convert the centimeter to meter now itself, or in the equation you can give it, no problem. So, the power of A, how we can find it? Reciprocal of the focal length of A in meters. So, you can, if you have to find it in meters, you can use a relation 1 by 10 centimeter is basically 0.1 meter, isn't it? 10 centimeter in meter means what? 10 by 100, that is equal to 0.1 meter. Likewise, 20 centimeter is 20 by 100, that is equal to 0.2 meter. Yes. Now, what is 1 by 0.1 meter? That is basically 10 diopter, isn't it? It is 10. That is basically 10 by 1. 10 diopter. Now, what about the power of B? Power of B, we can take it as 1 by FB. That is equal to 1 by, it is 0.2. That is equal to, yes, it is 10 by 2. That is equal to 5 diopter. Yes, so we got the power of A and power of B. See here we are not applying the sign convention because it is not specified which type of lens is given. So we are simply taking both as positive and find the powers. One has 10 diopter, the other one has 5 diopter. So which one has more power? Which one has higher degree of convergence? Definitely it is for lens A. Lens A has more power. Yes, PA is greater than PB. It has higher degree of convergence or divergence. Yes, that's how you are saying. Justify your answer. That's what we have justified right now, isn't it? So, higher degree of convergence is for, or divergence is for lens A. That is our answer. Next question. Draw a ray diagram to show the refraction of a ray of light through a rectangular glass slab when it falls obliquely from air into glass. So this is very important question. You have to draw and study this. Anyways, the figure is given in your textbook. You have to draw the rectangular glass slab. You draw a rectangle for that. Yes, this represents the outline or the rectangular glass slab. Now this is glass, and surrounding this glass we have air. Now A ray of light falls on this rectangular glass slab obliquely. So you have to represent the normal at the interface of air and glass. This is where the incident light is falling. So we are drawing the incident light ray likewise. And this will represent the angle of incidence because, yes, angle between incident ray and the normal. Now, what happens when the light enters from air to glass? Now, air is a rarer medium and glass is a denser medium. So, when light ray travels from rarer to denser medium, it will bend towards the normal. That's what we have seen experimentally, bend towards normal. So, we have to show that. So, exactly the line should have gone straight. But instead of that, as the medium is changing, the light ray will bend towards the normal. Likewise, sorry, I'll do it once more. It will bend towards the normal. So this angle made by this ray is called as the refracted ray, and the normal is angle of refraction represented by small letter r. Okay, now, inside the glass slab, the light ray travels in straight line path. And again, at this interface from glass to air, what happens? Again, there is a transition. The light ray is traveling from a denser medium to rarer medium. So, what happens to the light ray? It will bend away from the normal. So, you should by heart all these things. You should know thoroughly about these concepts. So when the light ray travels from denser to rarer medium, it will bend away from the normal. So at this point of incidence, you should draw the normal. Okay, this is normal. And light ray should have gone straight, but instead of that, it is bending away from the normal, making an angle of emergence here. Okay, yes, an angle of emergence is there. Now, this is the figure to represent the refraction of light ray through a rectangular glass slab. Along with that, don't forget to mark the lateral displacement, because lateral displacement means what? It is the shift happened to the emergent ray with respect to the incident ray. So we know that the incident ray should have gone in this straight line path, this red dotted lines. But it has shifted from its actual path. The emergent ray is going in different way, different path, isn't it? So this difference between the actual path and the emergent ray, this is called as our lateral displacement. So it is better to mark this lateral displacement also in your figure. So this is how you represent the refraction of light ray through rectangular glass slab. Next question. State Snell's law of refraction of light. Differentiate between the virtual images formed by a convex lens and a concave lens on the basis of object distance and magnification. So we'll answer the first part of the question. So first part of the question is to state Snell's law. Now, Snell's law of refraction is basically the second law of refraction. What does that say? So Snell's law states that, this is a direct question from your textbook. What is it? The ratio of sine of angle of incidence. How you represent sine of angle of incidence? That is SIN. That is the short form for sine trigonometric function. Yes. Sine of angle of incidence I to the sine of angle of refraction is a constant. This is basically your Snell's law. So when you state it, you have to write like that only. The ratio of sine of angle of incidence, sine of angle of incidence to sine of angle of refraction for a given pair of medium, for a given pair of medium and a given color of light, is a constant. So this is how you state the law, and then you should write this equation. Sin I by sin R is equal to constant. Now what does it mean by a given pair of medium and given color of light? Now if we consider a red light, refraction of red light through the glass slab, it will be giving a particular constant value. If we consider a green light, it will give another value. If it is a blue light, it gives another value. That means as the color of the monochromatic light, the single colored light changes, accordingly, this constant value also changes. Okay. Likewise, for a particular pair of medium, so if we consider the transferring of light from air to glass, its refractive index will be different. When we are considering the light ray traveling from glass to water or water to glass, or we can say kerosene to glass or air to kerosene. So for a given pair of medium and for a given color of light, this value will be constant. Yes, so that is Snell's law of refraction. Now, what is this constant value? This constant value is nothing else. It is basically our refractive index N. Refractive index, you know what do you mean by refractive index? Yes, it says how much the light ray got refracted when it entered to another medium. Okay. The measure of the refraction of light is given by this refractive index. So sin I by sin R is equal to the constant, that is N. So this is our Snell's law. Now second part of the question, we have to differentiate between the virtual images formed by a convex lens and concave lens. Now convex lens, we know that it is a converging lens, and convex lens has basically 7 ray diagrams. If you remember, you can say that it has 7 ray, not 7, I'm sorry, 6 ray diagrams. Now in almost all the ray diagrams, we have seen that convex lens is giving real and inverted image. Real and inverted image, it has a real focus, all these things we know. But in a particular object position only, it is giving virtual and erect image. And what is the position where the image is virtual and erect? It is when the object position is between the focus and the optic center. So when object position is between F1 and optic center, we can say that the convex lens will give a virtual and erect image which is enlarged. Yes, it is enlarged image. So if you have to draw and see, you can draw it. No problem. See, we have a convex lens. Roughly, I'm drawing the figure. This is our optic center. Let this be F1, this be 2F1, this be F2, and this is 2F2. Now, when the object is between F1 and O, we can say that considering two rays, one passing through optic center, it will not refract, it will pass in the straight line, and the other passing through, yes, parallel to the principal axis. After refraction, it will pass through F2. Like this it is going. So it is not meeting anywhere on the other side of the lens. But when you extend back these refracted light rays, you can see that these light rays will meet at a particular point. And that is on the same side of the object that gives the image position. Now this image is highly enlarged, virtual and erect. So when the object distance is between F1 and optic center, we can say that the image formed is virtual and erect image. This is the case of convex lens. But when we consider a concave lens, which is a diverging lens, it always gives a virtual and erect image. It has only two ray diagrams. As it is a diverging lens, it has a virtual focus. So it always gives virtual and erect image. Virtual and erect image. And the ray diagram of concave lens, it is very easy. Definitely it will be on the same side of the object, the image will be formed. So if we draw the ray diagram roughly, we can see if this is the object position somewhere between infinity and the optic center, we can see that the one ray passing through the optic center and the other ray which is passing parallel to the principal axis, after refraction it diverges out. isn't it? And this refracted ray, when we extend it backwards, you can see that at a meeting point, we are getting the image which is diminished in size, virtual and direct. It is always that only. So anywhere between infinity and the optic center or at infinity, concave lens always gives virtual and erect image. That is the object distance case. Now in case of magnification, we know that concave lens, it always gives a diminished image. So when we consider the magnification of concave lens, it will be magnification of concave lens, m will be always less than 1. It will be always less than 1 and positive. Magnification will be less than 1 and positive, whereas for a convex lens, magnification will be greater than 1 and it will be positive in this case. Why? Because it is giving an erect image above the principal axis. It is also enlarged. So the image size will be greater than the object size in convex lens, and in concave lens, the image size is less than the object size. So that's how you will represent the virtual images of convex lens and concave lens. So our next question. In our homes, we receive supply of electric power through a main supply, also called mains, either supported through overhead electric poles or by underground cables. In our country, the potential difference between the two wires, live wire and neutral wire of this supply is 220 volt. Write the colors of the insulation covers of line wires through which the supply comes to our homes. Now, only two wires are connected to our homes through the overhead supply, overhead electric poles. One it is live wire and the other one it is neutral wire. Now, there is one more wire, that is earth wire, that is connected individually for each houses or buildings, that is from earthing, that is called as earthing. Anyways, from overhead poles, we are getting live wire and neutral wire only, and live wire's insulation cover is red in color and neutral wire is black in color. So always remember, this will be like this only. Live wire will be having an insulation of red color, neutral wire has an insulation of black color. Now, when we consider the earth wire also, earth wire has an insulation made of green color. Keep that in mind. Next question. What should be the current rating of the electric circuit to 20 volt so that an electric iron of 1 kilowatt power rating can be operated? That is the first part of the question. First we'll answer it, then we'll move to the its sub question. So, it is given that we have an electric iron of power rating 1 kilowatt and the electric circuit works with an input voltage of 220 volt. Now, how much should be its current rating? That means how much current is required for the electric iron to work. What equation we can use here? P is equal to V into I. Yes, so I will be equal to P by V relation can be used. Now here power is given in kilowatt. First you have to convert kilowatt to watt. Why? Because current is measured in amperes. That is the SI unit. So 1 kilowatt is equal to 1000 watt. Substituting that, we get power as 1000 watt divided by 220 volt. Simplifying it, we will be getting 4.545, which can be approximated to 4.5 ampere. Yes, 4.5 ampere is the current rating of this particular electric iron. Now, next part of the question, so this was the first part. Next, the sub question is, what is the function of earth wire? State the advantage of earth wire in domestic electric appliances such as electric iron. Now, the function of earth wire is that it can be used as a safety measure in the electrical circuits, in the electrical devices. That is its function. It is ensuring a safety. Now, how does it work? what is the advantages of using earth wire? See, whenever we have a high power circuits or high power devices, so power devices, it utilizes more power, more current. Yes, we know that. Power devices will be having a metallic body in it. Now, which are those devices? Just like an electric iron, we can say the microwave, refrigerator. So these kind of high power devices has metallic body in it. And as it is metal, it is conducting. So this metallic body will have a tendency to develop some kind of leaked electric charges in it. If any chance is there due to some voltage fluctuation or due to malfunctioning or any problem, if this metallic body accommodates some kind of leaked electric charges, what happens when we touch them? Definitely we will get an electric shock. So it will lead to great danger, right? So in order to avoid that situation, we can connect the power devices using an earth wire. Why? The leaked charges or that extra charges developed in the metallic body can be eliminated through this earth wire to earth. How? Earth wire is basically a low resistive path for electric charges. So earth wire has less resistance. Why? Because its area of cross section or its thickness is very high. So due to less resistive path, these extra charges developed will be ejected or removed to the earth through earth wire, so that leaked charges will not affect the device or it will not give us any electric shock. So basically it is a safety measure. Earth wire is a safety measure. So our last question from this question paper. List 2 precautions to be taken to avoid electrical accidents. State how these precautions prevent possible damage to the circuit or the appliance. Now, first precaution is to use an earth wire, and the second precaution we can use is a safety fuse. Now, how does it work? So, earth wire we have already learned. How does earth wire work? It is basically a thick wire when compared to live wire and neutral wire. That means its area of cross section is much bigger than that of live wire and neutral wire. Therefore, it provides a low resistive path to the electric charges. Now, low resistive path. It will not allow all the electric charges to pass through it. Earth wire is connected to those devices with metallic bodies in it. Those devices which are high power devices. High power devices means what? Those devices which utilizes more power. So there may be chances of developing extra charges or leakage of electric charges to this metallic body of these devices, just like electric iron or refrigerator or microwave and all. When we touch them, sometimes we get electric shock. The reason is the formation of these extra electric charges or leakage of electric charges to this metallic body. When we touch them, we are getting the electric shock because our body is also a good conductor. So in order to avoid such a situation, we can connect earth wire to the metallic body. Now, this earth wire is offering a low resistive path for the electric charges. So if any leakage happened in that particular device, any electric charges developed in the metallic body, those charges will be removed to the earth through this earth wire. Okay, those charges will be removed to earth through the earth wire. Now, earth is like a ground state. It can accommodate infinite number of charges. It is neutral in nature, so it will not what we can say, it will not affect anything. So all these electric charges which is developed, which is not at all necessary needed for the working of the device, can be removed to earth through the earth wire. That's how we can prevent the dangers or electrical accidents using earth wire. Now, how does the safety fuse works? Now, safety fuse is a very thin fuse wire, which is a conducting wire, very thin conducting wire, which is connected to the electrical circuits in series. Okay, they will connect it to the electrical circuits in series. Now, how does it work? When any kind of voltage fluctuation happens or any unduly current flows through the circuit, and means any high amount of current, excessive amount of current flows through the circuit, what happens? According to Joule's law of heating, we know that H is equal to I square RT. That means heat energy will be produced through the circuit or the conductor when excess amount of current passes through it for a amount of time, right? So when excess amount of current enters to the circuit due to any voltage fluctuations and all, automatically heat energy will be produced, isn't it? Due to this heat energy, the temperature of the wire will be raised. If the temperature of the wire is raised, definitely this fuse wire will melt because fuse wire has very low melting point. Very low melting point metals are used to prepare fuse wires. So when high current passes through the circuit due to more temperature, more heat energy, due to low melting point of the fuse wire, it will melt and then break the circuit. Okay, break the circuit, which will cut off the current, which will block the current from further flow into the electrical devices. That is how we can save the electrical appliances from getting damaged, or we can avoid the electrical accidents using a safety fuse. So that's all for this question paper. Almost all the questions from physics part has been discussed. We'll meet in the next video with a new question paper. Thank you so much. Thanks for watching. Subscribe for more videos, hit the bell icon and join our learning journey.